Probability homework worksheet. List all of the possible outcomes, then give the probability of each outcome. Number 1, spin the spinner. Your possible outcomes are you could spin an A, a B, a C, a D, or an E. Then when you look at what is your probability of getting each outcome, you look at your total number. A, B, C, D, and E, there are 5 possible choices. Then, each one, there is only 1/5 of the possibility to get it. There is 1/5 the chance of getting an A, a B, a C, a D, or an E. Number 2, choose a polygon without looking. Your possible choices are you could pull a hexagon, a square, a triangle, or a trapezoid. When you look at your possibility or probability of pulling each one, your total possible choices is 4, and then there's only one of each in the box. So you would have 1/4 the chance of pulling the hexagon, 1/4 pulling the square, 1/4 pulling the triangle, and 1/4 pulling a trapezoid. Number 3, give the probability for the spinner. The probability of an even number. First, look at your possible choices to make your fraction. You have a 1, a 2, a 3, a 4, a 5, and a 6. There are 6 possible choices, so that goes on the bottom. Now, even numbers are 2, 4, and 6, so 3 would go on the top. Because 3, 6 can be reduced, there would actually be 1/2 the chance of spinning an even number. Number 4, what is the probability of spinning an odd number? Again, when you go to make your fraction, you look at total number chances. 1, 2, 3, 4, 5, 6. 6 goes on the bottom. The odd numbers are 1, 3, and 5. So there are 3 different odd numbers that goes on the top. Again, you have a fraction that can be reduced. So there's actually a 1/2 chance, a 1/2 probability of spinning an odd number. Number 5, what is the probability of spinning an 8? First, to make your fraction, look at your possible choices. 1, 2, 3, 4, 5, 6. There are 6 choices that goes on the bottom. When you look, there is no 8 on there, so there is no chance of spinning an 8, so it's actually 0. What is the probability of spinning a 3? Again, look at your possible choices. You have 6 possible choices, so that will go on the bottom of the fraction. There is 1 spot where there is a 3, so the 1 goes on the top. So you have 1/6 the chance of spinning a 3. What is the probability of spinning a 1? First, make your fraction. You have 6 possible choices, so that goes on the bottom. There's only 1 spot where there is a 1, so 1 goes on the top. And again, you have 1/6 probability of spinning a 1. For the next few, you'll be giving the probability of drawing a shape without looking. We are looking for the probability of drawing an oval. First, make your fraction and count how many total shapes there are. 1, 2, 3, 4, 5, 6. So 6 will go on the bottom of the fraction. Then, how many ovals are there? There are 2, so the number 2 goes on the top. You can reduce the fraction by dividing by 2 in the numerator and denominator, and your ending answer is 1/3. There's 1/3 probability of pulling an oval out. Now look at the probability of pulling a triangle. Again, you make your fraction. There are 6 total choices, and there is 1 triangle, so the 1 will go on the top. There is 1/6 probability of pulling a triangle out. Find the probability of pulling out a square. When you draw your fraction, again, you count the shapes. There are 6 total, and then you look at how many squares there are, and there are 3, so 3 goes on the top. You can reduce the fraction by dividing by 3 in the numerator and denominator, and you get that there is 1/2 probability of pulling a square. For the next couple, you're going to give the probability of drawing a card without looking. What is the probability of pulling an M? First, you do your fraction, count the number of cards. 1, 2, 3, 4, 5, 6, 7, 8. So 8 goes on the bottom. Now look at how many M's there are. There's 1, 2, 3 M's, so 3 goes on the top. That means there is 3/8 probability of pulling an M card. What is the probability of pulling an A card? Draw your fraction. There are 8 total cards, so 8 goes at the bottom, and then look for how many A's you have. There are 2, so 2 goes at the top. You can reduce this fraction by dividing by 2 in the numerator and denominator, so you actually get that there is 1/4 a chance of pulling an A card. Find the probability of drawing a T card. Again, when you draw your fraction, you know there are 8 total cards, so that goes at the bottom. Then find how many T's there are. There are 2. 2/8 can be reduced by dividing by 2. And you get that there is 1/4 a chance of pulling a T card. Now find the probability of pulling an H card. Again, you know there are 8 total cards, so 8 goes at the bottom. When you find how many H's there are, you see there is only 1, so 1 goes at the top, and there is 1/8 the probability of pulling an H card. Find the probability of pulling an M or a T card. That means it can be M or T. So you know that there are 8 total cards and 8 goes at the bottom. Now we can circle anything that's an M or a T. So there's 1, 2, 3, 4, 5. 5 will go on the top, and there's 5/8 of probability of pulling an M or a T card. On the simple probability worksheet, you're going to write all probabilities as fractions in simplest form. For the first couple, you're going to roll a standard number cube. So first you have to think about how many sides are there or chances are there. On a standard number cube, you have 6 sides. So you know that the fraction is going to be with a 6 at the bottom. If you have a 1, a 2, a 3, a 4, a 5, and a 6 on this cube, that means 4 is only there once, and you have 1/6 probability of rolling a 4. Find the probability of a multiple of 2. Again, remember that on a number cube there are 6 sides, and a multiple of 2 would be 2, 4, or 6 on the cube. So that means that there are 3 possible chances, and 3/6 can be reduced by dividing by 3 in the numerator and denominator. So there's actually 1/2 the probability of rolling a multiple of 2. Find the probability of rolling a number that is less than 3. So again, you have 6 possible choices. And on a number cube, only 1 and 2 would be less than 3 because it's not less than or equal to. So you have 2 possible chances, and 2/6 can be reduced by dividing by 2. So you get 1/3 chance of rolling a number that is less than 3. Find the probability of rolling a 1 or a 2. Again, on a number cube, you have 6 possible choices. And if you have a 1 or a 2 that you're looking for, there are 2 possible ways to get it. 2/6 can be reduced to 1/3, so there is 1/3 probability of rolling a 1 or a 2. Find the probability of rolling a number that is less than 7. There are 6 possible choices, and 1, 2, 3, 4, 5, and 6 are all numbers that are less than 7. So there are 6 possible ways to roll a number that's less than 7. You can reduce this to 1, which means that you will always roll a number less than 7. Find the probability of rolling a 7. You have 6 possible sides on a cube. And if they are 1, 2, 3, 4, 5, and 6, there are no 7s, which means there's 0 chance of rolling a 7. Now in the next set, you have a box with cards numbered 1 to 20. You want to find in number 7 the probability of picking a 1. There are 20 cards, so that goes on the bottom of your fraction. And the number 1, there is only one of those cards, so there would be 1/20th probability of picking a 1. Find the probability of picking a multiple of 10. Again, you have 20 possible cards. Multiples of 10 would be 10 and 20 only. So there are 2 of them, so 2 would go on the top of the fraction. 2/20ths can be reduced to 1/10. So there is 1/10th probability of picking a multiple of 10. Find the probability of picking a prime number. Remember that there are 20 total cards. Prime numbers are all of the numbers that are greater than 1 that cannot be divided by any other number besides 1. So if it has to be greater than 1, it can't be 1. 2 is only divided by 1 in itself. 3 is only divided by 1 in itself. 4 can be divided by 1, 2, and 4, so that's not a prime number. 5 can only be divided by 1 in itself. 6 can be divided by 1, 2, 3, or 6, so it's not 6. 7 can only be divided by 1 in itself. 8 has more than those 2 numbers. 9 has more than 2, 10 has more than 2, 11 can only be divided by 1 in itself, 12 has a whole bunch of factors, 13 can only be divided by 1 in itself, 14 has a few, 15 has a few, 16 has a few, but 17 can only be divided by 1 in itself, 18 has a few, 19 can only be divided by 1 in itself, and 20 has a few. So these are your prime numbers: 2, 3, 5, 7, 11, 13, 17, and 19. That is 8 numbers, so 8 goes at the top, and 8/20ths can be reduced to 2/5. So you have 2/5 probability of pulling a prime number. Now find the probability of pulling an even number. Again, you have 20 total cards, and even numbers would be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. That means that you have 10 total possibilities of it being even. So 10 goes at the top. 10/20ths can be reduced to 1/2. So you have 1/2 probability of pulling an even number. Find the probability of a number that is less than or equal to 12. Your total chances are 20. And then you have the numbers 1 all the way through 12, which means you have 12 numbers. 12/20ths can be reduced to 3/5. So you have 3/5 the probability of pulling a number that is less than or equal to 12. Number 12, the probability of a factor of 20. Remember that you have 20 possible choices. So now you need to figure out what divides evenly into 20. We know that 1 and 20 multiply times each other to get 20. Also, 2 and 10. 3 does not divide evenly into 20, but 4 and 5 do. So these are your possible choices of factors of 20. That means that you have 6 possible choices, so 6 goes at the top. 6/20ths can be reduced to 3/10. That means you have 3/10 probability of pulling a factor of 20. Now you're going to have a bag with 4 red, 6 blue, and 3 yellow marbles. You need to find the probability for 13 of pulling a red marble. First, you need to find out what's going to go on the bottom of the fraction. That's the total number of marbles. So you have 4 plus 6 plus 3, which is 13. There are 4 red marbles in there, so 4 goes on the top, and that means you have 4/13 of probability of pulling a red marble. Now find in 14 the probability of pulling a red or a blue one. Your total marbles is 13, so you put that at the bottom. We have 4 red and 6 blue, which equals 10. So 10 goes at the top, and you have 10/13 of a probability of pulling a red or blue marble. 15, find the probability of not pulling a green one. You have 13 possible marbles, and they are red, blue, and yellow, which means there are absolutely no green ones. So all of them are good for this. So when you add them all up, there are 13 that are not green, and 13/13 reduces to 1. That means that you will always pull one that is not green. Number 15, what is the probability of pulling a black marble? Remember, on the bottom, you put your total number of marbles, which is 13. We have red, we have blue, and we have yellow. There are no black in there, which means that there's no chance of pulling a black marble.